Good evening, dear students.
Good evening, ma'am.
Yes,
Good
good
evening.
evening. Good evening. Okay. So, we have completed two chapters. Okay. So, we have completed MCQ solving on first chapter solutions, and then we had seen alcohol, this one, haloalkenes and haloarenes, right? So, today we are going to start with the next chapter, that is D and F block elements. Okay. D and F block elements. Fine. So already we have discussed the important notes on this particular chapter. So I'm not going to go in detail with the synopsis. Okay. So directly we are going to start with the question. I hope you have revised. Okay. Revised about DNA block elements. Okay. So let us start. So what is DNA block element? So you know that in the periodic table. Okay. So our periodic table, it consists of 118 elements. So as there are so many elements, so what is done? So grouping of elements are done. Okay. So they are divided into different groups. How many groups they are divided? S, P, D, and F, right? Four groups they have divided. So S and P, this particular was included in the PU1, okay, and that is deleted. And D and F, it is included in your PU2. So in D and F block elements, what are D block elements? So the last electron of that elements will enter into the D subshell. Okay, so they are called as D. So they are called to be as D block elements. And these are called as what? Transition elements. Okay, D block elements, they are called as transition elements. Then what are F block elements? What are F block elements? Where they are placed? They are called as inner transition elements, right? Inner transition elements. And which are the category of elements which fall into F block elements? Anybody knows? Yes? F block elements. Which elements fall? Which are the group of elements? Lanthanides and actinides. Forgot? Lanthanides and actinides, right? So lanthanides and actinides. So these are the category of elements which fall into F block elements. Fine. So we have already discussed all the important things in our ACE sessions. Okay, so I'm not going to start again with the short notes. So directly we are going to solve with the MCQs. Okay, Janvi Kamath has said from 58 cerium to 71 lutetium. Yes, very good. Okay, very good. Question is, mercury is a liquid metal because, I hope the screen is more clearer. Okay. Okay. So mercury is a liquid metal because A, it has a completely filled d orbital that prevent dd overlapping of orbitals. B, it has a completely filled d orbital that causes dd overlapping. C, it has a completely filled s orbital. And D, it has a small atomic size. Yes, what is your answer? What is mercury, where it belongs to? Yes, what is the atomic number? Any idea about mercury and how is the state of this particular metal mercury? Any idea about this particular element mercury?
It has completely filled s orbitals, ma'am.
Okay, it has completely filled s orbital. Okay, so there are Akhila has answered as C. Sri Varuni has answered it as A. Okay. Any more answers, students?
Option C.
Aishwarya is has answered as option C. Janvi has answered as C. Lubna has answered as C. Vaishnavi has answered as C. Okay. So what is a mercury? Mercury, what is the state of the element? It is a element. Okay. So what is that symbol of the element mercury? It is represented by Hg. Okay. It is represented by Hg and its atomic number is 80. Okay. Its atomic number is what? Its atomic number is 80. Okay. And it is what? It is liquid in state. Okay. It is liquid. It is not solid in state, it is liquid in state, this particular element. Okay. Mercury, it is mostly seen in what? In your thermometers, right? Remember, in the thermometer, you can see mercury. Okay, mercury is there. Fine. So now this mercury, when you see the atomic, okay, when you write the electronic configuration of mercury, uh, so you are all right. So it is xenon. Okay, xenon, then 4F14, 5D10, and 6S2. Okay, so why so what is the answer? Why mercury is a liquid metal? Why it is liquid in state? Okay, I said mercury, it is in liquid state. Okay, so this, what is the color? It is silvery white. Okay, it is like silver color. Okay, it is having a silvery white, and this is a very heavy metal. Okay, it is a very heavy metal. Okay, so it is a silvery white metal, and it has a completely filled d orbital. Okay, and because of the completely filled d orbital, what it will do? It will prevent the dd overlapping of orbitals. Because so if the d orbitals were what, not completely filled. Okay, if the d orbitals were not completely filled, then what would happen? Then the dd transition would take place, dd overlapping would take place. But here you can see the in d orbitals, the maximum number of electrons which can be filled is 10, and already 10 electrons are filled. So why it is liquid in state? Because it has a completely filled d orbital. Okay. So A is the answer. So whoever have answered it as A, so is the answer. Okay. So your Janvi has a question. Mercury is liquid in room temperature. Then we freeze it in refrigerator. Will its state change? Okay. So when you have mercury, okay, when you have a mercury, so mercury, it is originally, okay, the metal, it is what? It is what you say? It is liquid only, okay, at room temperature. But when you cool it down, okay, so it is liquid at normal temperature. Now, how water will be at normal temperature, liquid in state? So like that, your mercury also at room temperature, it is liquid only. But if you cool it down, okay, if you cool it down, it will freeze, okay. And if you heat it, it will boil. So it is like water only, okay. If it is like water. So if you try to boil it, it will boil. If you try to freeze it, it will freeze, okay. So yes, it can be freezed in the refrigerator. Fine. So let us go for the next question. When sulfur dioxide is passed in an acidified K2Cr2O7 solution, the oxidation of sulfur is changed from. So when you are passing sulfur dioxide, okay, SO2 gas in an acidified potassium chromate, okay, in the potassium chromate solution. So potassium chromate solution, okay, which is acidified, means what? It consists of more H plus ion. Okay, so there is a H plus. So there is H presence of H plus ions in the dichromate solution. And what you're passing? You're passing sulfur dioxide. So what will happen to the this what oxidation of sulfur? Okay, so can you tell? A +4 to +6, B +6 to +4, C plus 4 to 0 and D plus 4 to plus 2. Okay. Anybody knows? Khila has answered it as A. One more answer, I've got it as B. Okay. Now here, what is potassium? Okay, one more answer. Janvi has answered it as A. Okay, now here, potassium dichromate. Do you know, students, what is potassium dichromate? Yes, what it acts as? Potassium dichromate. Lubna has answered it as A. Very good. Others? Okay. See here, potassium dichromate. Anybody knows what is potassium dichromate acting as? Anybody knows? Yes, very good. Okay. Shri Varuni has also answered it. It is a strong oxidizing agent. Okay, it is a strong oxidizing agent. Your K2Cr2O7, then your KMNO4. Okay, your potassium permanganate, your potassium dichromate. So these are what? These are strong oxidizing agent. So what is the role of the oxidizing agent? Yes, we have studied what is oxidation, what is reduction. Okay, we have studied all these terms. What is oxidizing agent? What is the role of oxidizing agent? It oxidizes other. Okay, it oxidizes other and itself, okay, itself undergoes reduction. So this is the role of a oxidizing agent. So what is the role of the oxidizing agent? It oxidizes other and itself undergoes reduction. Means what? Oxidation means was loss of electron. Okay, means what? The KMNO4. Okay, so your K2Cr2O7, it oxidizes other. So whatever the other this is present. Okay, the molecule or compound is present, so it will oxidize it. So that compound or the molecule, it will lose electron and K2Cr2O7 will gain electrons. Okay, so this is the meaning of oxidizing agent. So what it will do, it oxidizes other compounds and it will undergo reduction. Now, when you see SO2, okay, when you see sulfur dioxide, okay, now in sulfur dioxide, can you find out the this, what is that, oxidation state of sulfur? Okay, so let me find, you all also try. Okay, so how to find? We know that commonly oxygen, okay, commonly what is the oxidation state of oxygen is -2. Okay, so here there are how many oxygens? So there are 2 oxygens, so this will be -4 and this will be +4. So the charge on sulfur will be +4. Okay, so in sulfur dioxide, what is the charge? It is +4. Okay, so what it is doing? It is getting oxidized. Okay, it is getting oxidized. And so if we see the reaction, so let me write the reaction, how it reacts. So remember that in sulfur dioxide, the oxidation state is +4. So K2Cr2O7, okay, in the presence of H plus ions, okay, it is going to react, okay, with your sulfur dioxide. And what you're going to get? K2SO4 plus Cr2SO4 thrice, okay, plus 7H2O plus 3S. Okay, now what will happen to sulfur dioxide? So sulfur dioxide, okay, it will take the oxygen, okay, and the water, and it will form H2SO4. So find here the oxidation state of sulfur in this. So H plus, your each oxygen is -2, so -8. Okay, and this is +2, and this will be +6. Okay, and so +6. So sulfur, it will undergo +4 to +6. So when it is getting when in the presence of K2Cr2O7, sulfur, it is getting oxidized from +4 to +6. Okay, it is again losing 2 more electrons. +6 means what? 6 electrons are lost. So from +4, it will lose +6. So it is the first one. Okay, option number A. So whoever has answered as option number A is the correct answer. So what is sulfur dioxide? What is K2Cr2O7 doing? It is acting as an oxidizing agent. it is oxidizing other and itself undergoes reduction. So sulfur dioxide, so this is a reaction when K2Cr2O7 in the presence of H plus ions, okay, it forms K2SO4. So this sulfur, okay, this sulfur, it undergoes oxidation, okay, and it forms K2, it forms H2SO4. So from +4 oxidate, from the, okay, so from +4 to +6. Okay, I hope you have understood K2, H2SO4. So each oxygen is -2. So -2 into 4 is how much? -8. Okay, then hydrogen commonly what state it will be? +1. So there are 2 hydrogens, so +2. Okay, so -8 and this should be plus, right? +8. So how many? -8 +2, so it will be 6. So +6. So the oxidation state of sulfur is +6. So from +4, it will undergo +6 oxidation state. I hope your doubts are clear. Yes? Any? Is it clear? Shall we move for the next one? So these are the 2 questions which we have solved. Okay, fine. So let us go for the next one. Which of the following has the maximum number of unpaired d electrons? So they have asked maximum number of unpaired d electrons. Now, what do you mean by unpaired electrons? Okay. 1, 2, 3. Okay. Now here. Okay. So first one, second one, and third one. Can you tell me in which case number of unpaired electrons are more? Here, first we will see this and then we will go for the question. I should understand that you know what are unpaired electrons.
I mean,
One, in second, there are more unpaired electrons.
yes, ma'am. There is no unpaired electron.
Okay, no
And
unpaired electrons. Yes. But
sorry,
I
ma'am,
have
no paired electron. But in third, there is
okay.
only 2 paired electrons. Left others are not paired.
No. I want to know which are the maximum number of unpaired electrons. Okay, now observe all the 3 and you see in which of the case unpaired electrons are more. Okay, unpaired means what? There is no pairing. Okay, so 3 are there. So just see one more time properly.
Third case, ma'am.
In third case, okay. Janvi has also answered in third case. Okay, fine. So yes, in the third case, what you can see in the third case now here, there are 2 unpaired electrons. Okay, what do you mean by maximum number? Now here there are 3 unpaired electrons. But in the last case, there are 1, 2, 3 and 4 unpaired electrons. So this one, okay. So this is the meaning of maximum number of unpaired electrons. Okay, let us go for our question now. Okay, which of the following has the maximum number of unpaired electrons? Nickel. Okay, nickel is what? Nickel electronic config. What is this? It is 28. Okay. Then copper 29, zinc. Zinc 30. And Fe is 26. Okay, now based on that, Now, nickel, okay, when I write the electronic configuration, Ni plus 3. Okay, so this will be what? So write the electronic configuration.
Ma'am, for each element we should say, ma'am.
Yes, for each element you have to see and you have to tell which will have the maximum. Just try. So I'll write the electronic configuration, then you tell. Okay, argon, then 3D8, 4s2. Okay, argon is 18, then 3D8, 4s2. Copper, write for copper now. Copper is argon 18, okay, 3D10, 4s1. Write for zinc.
Three D10 4s2.
Yes, very good. So zinc is argon 3D10, 4s2. Then Fe. Fe is iron.
3d6 4s2.
Yes, very good. So argon 18. Okay. So 3d6, 4s2. Now the next question is, they have written plus 3, plus 1, plus 2, plus 2. So means what? These are the loss of electrons. So let us write. So nickel plus 3 means what? First 2 electrons will lose from here. Then 1 electron will lose from the 3D. So it will be 3d7. Then your copper 1 electron. Okay, plus 1. So what it will be? Copper plus 1 will be what? 3d10. Okay, it will be 3d10. Okay, it will be 3d10. Next, zinc. Zinc is what? Plus 2. Zinc plus 2 means what? These 2 electrons will be lost. So again, it will be 3d10. Okay, zinc plus 2 will be 3d10. Then Fe is plus 2. So it will be what? 3d6. Now write nickel. Okay, nickel is what? 3d7. So let me write. So 1, 2, 3, 4, 5. Then is what? Your, okay. Now copper, 3d10. So all are paired. So this is not possible. Okay. So third one is not possible. B1. Then our zinc is also 3d10. So these are also all paired. So this is also not possible. Now write for only nickel plus 3 and Fe plus 2. So Fe plus 2 is what? 3d6. So 1, 2, 3. So write the electronic configuration 1, 2, 3, 4. So your nickel is 1, 2, 3, 4, 5, 6, and 7. Now write it for your iron. Okay, so it is 3d6. So 1, 2, 3, 4, 5, and 6. So first the electron filling will take singly and then the pairing will take place. So which principle is this? Do you remember which is the principle? First, the electrons are filled singly and then the pairing will take place. So which is this principle, students? You have studied this in first year. Hund's rule. Yes, very good. Janvi has answered it right. Hund's rule. It is Hund's rules of multiplicity. Okay. So the electron first, it will pair singly and then the first the electrons are filled singly and then the pairing will take place. Now, which is having the maximum number of electrons? So here there are 3, 1, 2, and 3, and here there are 4. So option number D. Okay, option number D. Is it clear now? What is the maximum number of unpaired electron? Is it clear? The third question. Third question, is it clear? Yes. Okay, fine. So yes. So let us go for the next one. So remember, okay, so like this only different elements will be given from the D block, and they may ask you to find the maximum number of unpaired D electrons. Okay. Next question. The incorrect statement in respect of bromyl chloride test is A. Formation of lead chromate, B. Formation of chromyl chloride, C. Liberation of chlorine, and D. Formation of red vapors. Okay, so you might have done this chromyl chloride test. So did you start with the salt analysis in your college? Did you start with the laboratory, your practicals? Or even in the first year, you might have studied, but you might have not done this chromyl chloride test. Okay. So what is this chromyl chloride test? It is a test for confirmation of what? Confirmation of chlorine. Okay, it is a confirmation of chlorine test. That is a chromyl chloride test. Now here, which is the incorrect statement in respect to chromyl chloride test? So chromyl chloride test, where it is used in the confirmation of presence of chloride ion. Okay, in the presence of chloride ion. Okay, so chloride ion in the qualitative, your inorganic analysis, in your salt analysis, right? Now, what we are doing here, we are taking, so what is the test, chromyl chloride test? In the test tube, okay, what we are doing, we are taking the salt, which is given, small amount of the salt, okay, and what we are going to do, we are adding concentrated H2SO4. What we are doing, we are adding concentrated H2SO4 to that, and then we heat it. What we are doing, we are going to heat it. We are going to heat it. Okay. Okay, we are going to heat this. Then what you are going to get? So after heating, vapors can be seen. Okay, vapors can be seen. This vapors, okay, they will be deep red color vapors. So deep red color, red orangish type of vapors can be seen. And this tells you that chromyl chloride vapors. So this confirms the, yes.
Orange red vapors are evolved, ma'am.
Or orange red.
Yes, ma'am. Orange red, ma'am. While we are doing experiment, we
Yes.
got that orange.
Yes, it is orange red. Okay. So you can see, and you get very irritating smell, right? When you do this test, you get very irritating smell. Your nose and your throat starts to itch, right? So this is a so you get orange reddish vapors. Okay, and this tells you that chromyl chloride test is evolved. Now this is how we do the test. Okay, now what are the reactions behind this test? Okay, so the test involves what? Suppose the given salt is NaCl. Okay, if the given salt consists of Cl minus, then only it will show you orange red vapors, right? If the salt does not consist of chloride ions, then it will not show this orange red vapors. Now suppose I have the salt NaCl. Okay, so what I'm doing for NaCl, I'm adding H2SO4. Okay, concentrated H2SO4. So what it will form? It will form NaHSO4 plus HCl. Okay, now after this, what we are doing for that? After evolving the gas, okay, we add K2Cr2O7 powder. Okay, Cr2O7 powder. This K2Cr2O7 powder, again, it reacts with the concentrated H2SO4 and it forms potassium hydrogen sulfate plus chromic oxide is formed. Okay, now here this chromic, whatever the oxide is there, it reacts with the HCl. Okay, so this is the inside only, all the reactions are happening in the test tube and it will form a chromyl chloride. Okay, this chromyl chloride is nothing but the gas vapors. Okay, so chromyl chloride test. Now this chromyl chloride, what you get? Chromyl chloride, so the vapors. Okay, now what you are going to do? Through that vapors, you are passing in another test tube, you are taking NaOH solution. Remember, right? In the another test tube, you are taking NaOH solution and you are passing that vapors from this test tube, whatever the vapors are released, so that you are passing into this. And then what you are doing to this test tube, you are shaking it, right? Just a shake, because the vapors will be collected at the top. Then this solution will turn yellow color, right? This solution will turn yellow color. So yellow color is nothing but sodium chromate is formed. What is formed? Sodium chromate is formed. Na2SO4 is formed. Na2 solution. What we are doing to this solution? We are adding lead acetate. Okay, we are adding lead acetate and acetic acid. Okay, and then what we get? We get
Bright
a yellow PPT. Yes, bright yellow PPT, and that bright yellow PPT, it is a lead
Chloride
chromate. Yes, very good. Okay, so it is a lead chromate. So this is the reaction. Okay, so everything you are done practically. But what is the theory that you are going to study in your regular, right? Like this. So, so this is a test, and behind that test, these are the reaction. So what is the incorrect? So lead chromate is formed. This is correct. Then formation of chromyl chloride. This is also correct. Then formation of red vapors. This is also correct. Liberation of chlorine. Is there any liberation of chlorine? No. So option number C is the, yes, option number C is the incorrect statement. Okay. So this is the reaction between the chromyl chloride test. Very important test, chromyl chloride test. They may ask you in your Viva also. So in the practical Viva, they may ask you about chromyl chloride test while doing the salt analysis. So you have to do it properly. You should get this yellow solution. After, you have to be proper in passing the gas into red. You have to collect this red vapors into the test tube containing NaOH, right? Then it will turn yellow solution. Then to that you are going to add lead acetate and acetic acid. What you are doing? You are neutralizing the solution. You are going to get lead chromate. So this is the reaction behind this test. So option number C. I hope all have got it. Yes, Lubna has answered. Janvi has answered as C. Okay. Okay, fine. So let us go for the next one. The magnetic moment of a transition metal, okay, transition metal ion is square root of 15 bm. Okay, what is bm? Bohr magneton. Okay, Bohr magneton. Therefore, the number of unpaired electron present in it is. So this is very important. So magnetic moment also, this type of questions are very important. So the magnetic moment of a transition metal ion is, the answer is 15 bm. They have asked how many number of unpaired electron are present in it. So this is a reverse question. Okay, this is a reverse question. So to calculate the magnetic moment, so what you have to know first, to calculate the magnetic moment, the formula is square root of n into n plus 2 Bohr magneton. Okay, remember this formula. So what is, how is Bohr, your magnetic moment calculated? That is square root of n into n plus 2 Bohr magneton. Okay. Now, what is n? N is the number of unpaired electron. Okay. N is what? N is the number of unpaired electrons. Now here,
Ma'am, for this formula, there is no element, na ma'am, here. How we should
yes,
calculate, ma'am?
please repeat.
Ma'am, if element is there, we can calculate this, ma'am. But there is no element, na ma'am. How should we calculate?
Yes. So only the question is little twisted, no? So only they have asked like this. Okay, in a twisted manner. If they give you directly element, you can easily calculate. So they have given
Okay,
you
ma'am.
directly the so they have given you directly the answer. So let us see. Okay, I'll tell you stepwise. So this is a formula. First thing, remember the formula. The formula to calculate the magnetic moment is square root of n into n plus 2 Bohr magneton. The unit is very important, Bohr magneton. What is n here? N is the number of unpaired electron. N is what? N is the number of unpaired electron. Okay. Let me zoom this again. Okay, so N is the, so magnetic moment is equals to square root of n into n plus 2 Bohr magneton, where n is the number of unpaired electrons. Okay. Now here, what is our magnetic moment? That is mu is square root of 15. Okay, so let us see. So therefore, square root of 15 is what? It is square root of n into n plus 2. Okay, so if we remove square root, so it will be 15 is equals to n into n plus 2. So what is possible? So you have to, if I, so 4, if I put 4, okay, so these are the possible number of unpaired electron. So 4 plus 2, so 4 plus 2 is 6, 6 into 4 is 24. So this is wrong. Then next is what? If I take it as 1, so 1 into, so 3, 3 ones are 3. So this is also wrong. So B, then 2, if I take n is equals to 2. So 2 into 2 plus 2. So it is 4, 4 2s are 8. So this is also wrong. Let us take the last one, 3. So 3 into 3 plus 2. So 3 2s are 6. 3 plus 2, 5. 5 3s are 15. So which is the answer? D. Got it now? Yes, Janvi and Lubna has answered is that D. Okay, got it now? How you have to find? Aishwarya?
Yes,
Okay.
ma'am. I have found it, ma'am.
Yes. Okay. So remember this. Okay. So remember this. So directly if they give you element, then you know how to find. So this is in a twisted manner. Okay. They have asked you little in TDS manner. Okay. Ulta they have asked you. Fine. Let us go for the next one. So D is answer. Let me take this to the next one. Okay, so the spin only magnetic moment of Mn plus 4 ion is nearly. Now you know, okay, this you can easily find out, I think. Okay, this you can tell me easily. What is the spin only magnetic moment of Mn plus 4? So Mn first, Mn, what is Mn?
Ma'am, is it -4 or +4 ion?
Plus 4 ion. Plus 4. Manganese, okay, it is manganese. Manganese, what is the electronic configuration? Manganese is argon 18, 3d5, 4s2. (25). Right, it is 25. So Mn plus 4 means what, students? Plus 4 means 4 electrons are lost. So how 4 electrons are lost? First 2 electrons are lost from here, 2 electrons from here. So it is argon 18 and it is 3d 3. Okay, 3d3. So so when I write the electronic distribution, so it will be 1 2 3. So n is 3. So put the formula square root of n into n plus 2. So it is 3 into 3 plus 2. So it is 3 plus 2 is 5. 5 3s are 15. Okay. So 15. 15. If you see the square root of 15, what is the answer? Square root of 15, just see.
3.87.
Okay. So square root of 15. Yes, 3.87. So 3.87 is nearer to what? It is nearer to option number C. It is option number C. Okay, so let us see who all have answered. Akila has answered as C. Okay, only one answer. Okay, so it is 3.87. No. Okay, 3.87. If it is 3.3, then you can consider it as 3. Okay, many students have answered as A. See here, when it is 3.3, if it is less than 5, okay, 3.4, 3.3, then you will consider it as 3. If it is more than 3.5, if it is 3.6, 3.7, then you have to... What? Then it will be 4. Okay, so it is 4. The spin only magnetic moment, it is 4. So because it is 3.87. Okay, 87. So you have to round out to the next number. So 4 and 4 is the answer. Let us go for the next one. Yes, Janvi has also answered C. Gupna has answered it as C. Let us go for the next one. Yellow precipitate. Yellow precipitate formed during the chromyl fluoride test is chemically A. Chromic acid, B. Lead chromate, C. Lead acetate, and D. Sodium chromate. Yes, I have explained you this. You can just answer it. Why the yellow color precipitate? So precipitate and solution is different. Solution means what? It will be like water. Okay, only yellow color water like it will be. Solution means. Precipitate means what? It will be like curd form, right? You know the difference between a solution and a precipitate. Precipitate will be like curd form. How white color curd will be there, like that yellow color curd like precipitate will be. Precipitate means what? It is an insoluble substance. Okay, it is an insoluble substance. So yellow color precipitate is different, solution is different. Okay, so how this yellow color precipitate is formed? The last one, it is due to what? Okay, I've got
Lead
the
acetate, ma'am.
think again. Lead acetate is chemically okay. Just a second, I'll see the answers. Okay, so let us continue. Shri Varuni has answered it as B. Janvi has answered it as B. Akila has answered it as D. Dupna has answered it as B. Yellow precipitate. Yellow precipitate formed during the chromyl fluoride test is chemically. Yes, others? The answer is what? It is due to lead chromate, right? It is due to lead chromate because after passing the red vapors, so what we have done in the test tube, okay, the salt is there, you have added H2SO4 and you have added K2Cr2O7, then you have heated it. After heating, the fumes are released. That fumes you are collected in another test tube containing NaOH. Okay, the fumes are collected. Then it becomes what? It becomes a yellow solution. To this yellow solution, you are going to add what? Lead acetate, and you are going to add acetic acid. So what will happen? It will become lead acetate. Okay. It will become, it will become what? It will lead chromate. Okay. It will form lead chromate. So option number B is the answer. So yellow precipitate formed during the chromyl chloride test is lead chromate. So option number B. So whoever have answered it as option B, it is the correct answer. Let us go for the next one. The spin-only magnetic moment of Fe+2 ion in Bohr magneton is approximately. So iron is 26. So argon 3d6, 4s2. Okay. So Fe+2. So Fe+2 is what? Argon 3d6. So like write the electron distribution. So first the electron should be added singly, and then the pairing will take place. So number of unpaired electrons are how many? So there are how many unpaired
4,
electrons
ma'am.
here? Yes. So there are 4 unpaired electrons. So put n is equals to 4. Our formula is what? Our formula is just a second. Okay, so our formula is square root of n into n+2 Bohr magneton. So n is equals to 2. Okay, because there are 4 unpaired electron, 1, 2, 3, and 4. So 4 plus 4 plus 2. So it is 4 plus 2 is 6. 6 into 4 is 22. Now find out the square root of 24. Square root of square root of 24. 4.89 means what?
It is related to 5, ma'am.
4.85. Yes, option number
Option C, ma'am.
C. Yes, very good. Okay. So yes, Sri Varuni has also answered it right. Very good. Aishwarya has also answered it right. Very good. Lubna has also answered it right. Very good. Okay. So now I hope you have understood the questions on Bohr magnetar. Okay. Let us go for the next one. Which one of the following has a magnetic moment of 1.75 bm? Now you do this similar problems we have done. I will not do this directly. I'll tell you the answer. So you have to tell me, solve this and tell me. Which of the following has a magnetic moment of 1.75 for magneton? Ninth one. Shri Varuni has answered it as A. Mu is equals to N into N plus 2 Bohr magneton. Okay. Now titanium plus 3. Okay. So if I write this, so it will be 3D1 4s0. Okay. Then vanadium plus 3. It is 3D2 4s0. So this is after the loss of electrons. Okay. I'm writing directly the answer. So chromium plus 3. It is 3D3 4s0. Then Fe plus 3. Fe plus 3 is 3D5 4s0. So the number of unpaired electron here is 1. Here it is 2. Here it is 3. And here it is 5. So if you put the values, okay, in this particular formula, if I put n is equals to 1, okay, 1 plus 1, 1 plus 2, so 3 ones are 3. So square root of 3, okay, square root of 3 is nothing but 1.75. So option number A. Yes, Sri Varuni and Lubna have answered it correct. So option number A will be the answer. Okay. So first, what is this? So first write for titanium. Okay. Then loss of 3 electrons. So minus the 3 electrons. That is titanium plus 3. So whatever the number of unpaired electrons are there, put in the formula and see which will come 1.75. So it is option number A. Okay. Fine. Let us go for the next one. So I hope we have solved 9 questions till now. I hope it is clear. Okay. Next one question. The spin-only magnetic moment of Ni plus in aqueous solution would be atomic number of nickel is 28. So what is the spin magnetic moment of nickel plus? So nickel is 28. So it is argon 18, 3D 8, 4s2. So nickel plus means what? So nickel plus, I think it is nickel plus. Yes, it is nickel plus 2. Okay, take it as plus 2, not plus 1. It is nickel plus 2. Let me do the changes here. So it is nickel plus 2. Okay, so it is nickel plus 2. So nickel plus 2. So what will happen to nickel plus 2 now? Nickel plus 2 will be now 3d8. Okay, write the electrons. So 1, 2, 3, 4, 5, 6, 7, and 8. So the number of unpaired electrons are 2. So 2 into 2 plus 2. So it will be 2 into 4. 4 2s are 8. So square root of 8. So option number D. Who all have got it as option number D? Yes. Akhila has got, Shivaruni has got. Okay, very good. Okay, fine. Lubna has got. Okay, very good. Okay. Silver iodide is used for producing artificial rain because AGI. So in creating the artificial rain, silver iodide is used. That is AGI is used. Why? What is the reason why AGI is used for producing artificial rain? The answer is what? Because it has a crystal structure similar to ice. Okay, option number C. Yes. Remember that because silver iodide, it has a crystal structure like ice. So because of that, it is used in the production of artificial rain. Okay. Fine. So remaining questions, I think we will discuss in the next class. Okay. So we have discussed some 11 questions today. Okay. Remaining questions. Okay, so we have discussed some 11 questions today. So the remaining questions we'll be discussing in the next class. Okay, so we are going to continue with the same topic in the next class. So any
Ma'am,
doubts
for
up to
11th one, what is answer, ma'am?
which one?
11th one, ma'am.
Okay, so silver iodide, it is used for producing artificial rain because AGI, okay, that is your silver iodide, it has a structure similar to ice. Okay, how is the ice? How ice looks, right? Your ice. So similar crystal structure it has. So your silver iodide, it is used in producing the artificial rain. So remember this. Okay, fine. So the remaining questions, so we will be discussing in the next class. Okay, so some more questions are there. Fine. So any doubts up to your students? Anything you have to ask, you want to ask me? Any doubts? So if you find any more books, any questions, so please solve regarding yes, Friday we'll be having the first test, okay, on solution. So be prepared, do well. Fine. So, so whatever the topics are done. So, if you have any book, okay, in your college library or if with your friends, so try to solve maximum number of questions. Okay, so that it will help you. So first make your basic strong. Okay, so already, okay, so already we have discussed in our ACE classes, all the basics are taught. So please prepare that. Okay, and then so similar the questions also you have to solve. Okay, fine. So fine. So by this I shall end the session here. Okay, so we'll meet in the next week. Thank you.
Thanks, ma'am. Bye, ma'am.